All right, so here we go. Functions. We want to use function notation or a graph to evaluate functions, determine if an equation or graph represents a function, and find domain and range with interval notation. So hopefully most of this is somewhat familiar. It's just kind of jogging our memories here. So first of all, function notation. That was that f of x, g of x, h of x, things like that. So if we are going to evaluate a function using function notation, this thing is sort of like saying f is a function of x, g is a function of x, h is a function of x. So if I have something like f of x equals 3x plus 99, I want to be able to use that to figure out what is f of 1 or f of 2 or f of a million. So wherever we have the x value, we replace the x in the function, which gives us 102. So things like that are what we want to be able to do. Let's see. We also want to be able to, if we're given, if we're told f of x equals 105, we want to be able to find the x value that goes with that. So what we would do then is go, okay, 105 equals 3x plus 99. And then we would solve for x. Okay. So those are two things that we want to be able to do using function notation. The other thing that we want to be able to do concerning function notation and evaluation of functions is take a graph and be able to evaluate a function based on a graph. So let's say we had something like this. We might be asked something like, evaluate what is f of 2. And usually in these cases, it will be very obvious what it is. Like the graph will be more nicely drawn than I typically draw graphs by hand. And if there's not a nice graph associated with it, then it'll have a function equation written out for you. But at any rate, f of 2, we would just go, okay, over to 2 on the x-axis. And notice that f of 2 is 3. And then vice versa, if we want to say when is f of x equal to -2, we would want to find the x value associated with that. So we'd go, okay, well, -2 is right here. And that's associated with the x value 5. Okay. So that's using function notation or using a graph to evaluate functions. Next, what we want to be able to do is decide if something is a function or not. So to do that, we're going to move some stuff out of the way. Okay, is it a function? All right, there was a test to determine if a graph was a function or not. Does anyone remember what that test was called? Probably been a while. It was something to do with a line. Yeah, Asher's got it. Vertical line test. Yes, that is how we determine if a graph is a function, just by visually looking at things. So one test we have for graphs is the vertical line test. Okay, so if you're deciding if something is a function or not, graph it. So we might see something like this, where if I, like a parabola or something like that, if I draw a vertical line anywhere on here, it's only going to run into my graph one time. So this would be a function. But if we've got something like this, the sideways parabola, and I draw a vertical line, it runs into my function more than one time. So this would not be a function. Okay, so that's how you tell graphically. If you're just given like a chart or something like that, you can also tell, but you wouldn't use the vertical line test. Or I mean, I guess you could if you plotted all of the points, but you don't have to. What you can do is, for a chart, let's say we've got X values and Y values going 1, 2, 3, 4, 5. We'll go 5, 4, 3, 2, 1 there. If each X value only has one corresponding Y value, then it's a function. So this one is yes, since each X value has only one corresponding Y. But if we had a chart like this, where we have, I don't know, 1, 2, -3, 1, 4, 2, and we've got something like that, we notice that there's repeating X values that correspond with different Y values. So for this one, it would be no, because X values have more than one Y value. Okay, so that would make it not a function. You could go and plot those points and use the vertical line test there as well. But on a chart like that, it's easier to just look at the chart and decide. Okay. Last thing for today is domain and range. And domain and range is probably where we spend the bulk of our time, just because some of this might be new notation. So, domain and range. First of all, does anyone remember what domain and range correspond to? Which one's X, which one's Y? Anyone remember? Yep. Domain is X, range is Y. Okay. So the domain is the X values, the range is the Y values, and there's some notation with how we talk about what the domain and range consist of. And there's a couple different types of notation that you'll see, and there's a particular type of notation that you might have already seen that I like us to use the most often. It's going to be the most frequent type of notation that you see for this. Okay, so notation. Kind of a side note here, but let's say that my domain, I wanted to denote X values less than 50 only. Okay, so there's two different types of notation that we'll kind of see here. One of them is interval notation. So interval notation, X values less than 50 would look like this. 50, or sorry, not 50 infinity, the other way around. In my notes, I had greater than 50. Negative infinity to 50. And it would be an open interval here. If it was less than or equal to 50, it would be a closed interval here. But it's always open on the infinity side. Another way that I could write this is in something called set notation. And set notation looks like X, a line here. This line kind of means such that. X such that X is less than 50. So that's another way that you might see a domain or a range expressed, well, a domain expressed since it's X values. Another example would be if I wanted to say something about, like, maybe my domain is all real numbers. One way that you can talk about all real numbers is just by saying all real numbers. But the interval notation way of saying it is negative infinity to positive infinity. And then the set builder way of saying it is X such that negative infinity is less than X, less than positive infinity. Or X such that X is included in the real numbers. So that fancy, the R with the line through it means real numbers. That's a set of real numbers. So those are different ways we could write it. This is the way that we will typically write it. Okay. Or if I wanted to say 1 less than X less than or equal to 4. Let's say we wanted to be inclusive here on one end. Then it would just be 1 comma 4, but it would have a bracket on this side instead of a parenthesis, so to show that we're including the number 4 in our set. Or if you were doing it the set builder way, X such that 1 is less than 4 is less than, X less than or equal to 4. Okay. So again, this is mostly the notation that we will be using. But occasionally in things like IXL especially, you see this sort of a notation, which is why today we're not doing IXL, or one of the reasons that today we're not doing IXL. Okay, so using this notation to talk about domain and range. We're going to do some examples. So let's start basic. Let's start with just a line. All right, so remembering domain and range here. Okay, so for a line, notice we have arrows on both ends. We have one arrow that's pointing up and to the right, and one arrow pointing down and to the left. That means that our domain, since we've got arrows pointing to the right and to the left, covers the span of all real numbers. So that would be negative infinity to positive infinity. And the range does the same thing. We have one arrow pointing up and one arrow pointing down. There are no excluded values here. So this is also all real numbers. Negative infinity to positive infinity. So this is typically the way we would write our answer there. But when we start seeing things like parabolas or piecewise functions or all kinds of different things, we start having to sometimes exclude a value. So we'll talk about that as well. Or exclude multiple values even. So what if I have something that looks like this instead? So my domain, I have an arrow that's pointing out to the left and an arrow that's pointing out to the right. The domain stays the same as being all real numbers, negative infinity to infinity. But the range does not include all of the numbers. It has a highest value. So the arrows are only pointing down, so that means it does go to negative infinity, but it only goes up as high as 3. And it would be inclusive since it actually reaches 3. Okay. Any questions up to this point? Is this starting to look a little bit familiar? All right, go ahead and type in the chat. If this is starting to look familiar, say yes. If it's completely can't remember any of this, type no. And if you're kind of so-so, type meh. Unfortunately, yes. Okay. Looks like mostly kinda and yes. Okay. We'll go through another example here. And then the nice thing about the assignment for today is it's very much a choose your own adventure in a couple ways. It's helping yourself to review and remember this stuff. So we'll do another one. What if I wanted to exclude a value? Like, let's say I've got something that looks like that. So from my domain, we have to exclude the value 1. From my range, I need to exclude the value 2. So what I would do, if I was going to use my interval notation, we know that the domain goes off to negative infinity. We know that it goes off to positive infinity. There's just a spot in the middle at 1 that we can't use. So I know I've got negative infinity all the way up to 1, not inclusive. And then starting at 1 again to positive infinity. This effectively excludes the 1. And in order to include both of these sets, I just put a U here to show that I'm including both of the sets. That means union. So I'm including both of these sets in my domain. I'm just excluding the number 1. And then we do the same thing for the range. We know that it goes down to negative infinity. And we know that it goes up to positive infinity, but we have to skip the number 2. So whatever number you're skipping goes in the middle here. That's how we would skip a number. Okay. So we've got domain, range, function notation, determining if an equation is representing a function. Are there any questions at this point? Any numbers? Yeah, I can explain that one again. So if we're going to exclude a number, since here we've got like a hole in our function, then in order to do it for the domain, I know that this is going to reach all x values except for 1. 1 will not be an x value of this function. So what I do is we go, okay, well, I know that it goes off to negative infinity, so we know negative infinity is part of this, and it goes up to 1, but not including 1. So we don't do a bracket, we do a parenthesis instead. And then I know it starts at 1 and goes to infinity again, but not including 1. So that's where the 1 to infinity comes from. So if you're going to exclude a number, you just break up your sets. So you break it up into 2 pieces, wherever you have your discontinuity here. And that's what goes kind of in the middle here, so that you can get rid of that value. And then you do the same thing for the range. Since we know that 2 is never a y value here, so we go from negative infinity to 2, not including 2, and then from 2 to positive infinity, still not including 2. So that's how it would look in interval notation. Most of the time, the ones that you guys are going to see, especially today, are going to look like this kind of an idea here. This one will come more into play when we get into talking about continuity, which is in, I believe it's either 1.2 or 1.3. We get to talking about continuity. But anyway. If you're looking to express inequalities as in this kind of a notation here, I want to review that really quick. Inequalities as intervals. So if I have less than or equal to's on both sides, then my interval would be the interval from A to B, inclusive with brackets. If it's strictly less than, then that would be the parentheses. If it's less than or equal on one side, then it would be a bracket on one side and a parenthesis on the other. And then same idea, but in reverse here. With infinity, if I have like x values greater than or equal to some value a, then we include a, but we send the rest of it off to infinity. And on infinity, there's always a parenthesis. If I have less than or equal to some value a, then we have negative infinity up to a, including a. If I have x strictly greater than some value, then it's an open interval here. If it's strictly less than, then it's an open interval. And then if I have negative infinity to infinity, then it's just negative infinity to infinity here. So if you see something written as an inequality, in order to write it as an interval, these are kind of guidelines to follow. Okay. So the next thing I'm going to do is set up the assignment for today. And let me find it. Tab is hidden. There it is. Okay. So this is what our assignment looks like. I'm going to kind of walk through and explain what we're doing here. So if you click on this, it's going to take us to a Khan Academy thing, if it'll load. Here we go. Okay. So it's got this whole lesson about functions and things like that. So if you scroll down, you can see if there's something that you need to brush up on, there's videos here. If there's stuff that you want to practice before you take the little quiz at the end of the section, there's things that you can try. So it does a couple of sections, and then there's a quiz. So you click on Take the Quiz, and that would be quiz 1. It would just go over the material that's up here, evaluating functions, inputs and outputs of functions. So then you go down and go, okay, now we can do functions and equations, interpreting function notation, domain and range, things like that. And then you get quiz 2. That'd be the next one. And then it talks more about domain and range and recognizing functions and vertical line and stuff like that. And then there's quiz 3. So the ones that we're going to do today are quiz 1, quiz 2, and quiz 3. And the nice thing about the quizzes is that you can take them again if you don't get a very good score the first time. So wherever you feel you need to practice, feel free to practice or try again on stuff. That's a good question. I'm going to try to make it so that logging in actually tells me something. Let me see if I can do it actually. Where'd the saved one go? Here it is. Okay. I believe I just assigned on Khan Academy quizzes 1, 2, and 3. So please do log in with Google, because then I think I can see what you guys have done. But yeah, so this is my first time using the Khan Academy lesson thing. So sorry if I'm not amazing with the technology yet, but please do log in. So I'm logged in up here. So you would click sign in and do it sign in with Google. And let's see. So yeah, we're doing quiz 1, quiz 2, quiz 3. As many times as you need to get to 100% is your goal. And then along the way, if there's something that you need to work on, you can get practice on those practice problems here. You can watch videos along the side here if there's something that you feel like you need to learn again. Any questions at this moment? You can start with the quizzes if you would like to. You can, that's probably a good way to start, is with quiz 1, and then it'll recommend stuff. If you get one wrong, it'll recommend that you try a certain section using the practice, or it'll recommend a certain video. So yeah, I think I would start with the quiz. If you get 100% on quiz 1 the first time, then maybe jump down to quiz 2, and you get 100% on quiz 2, jump down to quiz 3. Yeah, that's the strategy that I would use. And then if it tells you something to work on, it like stars little things that it recommends that you watch or do to get clarification. Okay. And then this class is over at 1:45. So come back at 1:40 to do the exit ticket and debrief. Otherwise, if you have questions, stick around. Or if you just want to leave this open, stick around. Otherwise, you're free to go start working. Possibly. So when you go to the link up here, there should be something that says sign in. Were you able to click on that? Okay, cool. Thanks, you too.